students, welcome back. In this lecture we are going to discuss about gravitational binding energy and different types of masses. We have also collected some important concept building questions for you which comes play into daily life. So we will discuss here in this part also. So let's get started. Hello students, welcome back. In previous part we studied about escape velocity. Now we are going to study about gravitational binding energy. The minimum energy needed to take the particle infinitely away from the earth is called binding energy of the earth particle system. Means here we are trying to throw an object infinitely away from the earth. Means we are trying to throw an object away from the field of the earth. In previous part, in escape velocity, final equation of escape velocity, that was half mu square plus minus gmem by re plus h is equal to half mv square greater equal 0. Since RHS is greater equal 0 due to kinetic energy, since kinetic energy will never be negative, so LHS also greater equal 0. So this is the minimum energy needed to take the particle infinitely away, throw the particle infinitely away from the earth. Okay, so solving this equation, half mu square is greater equal gmem by re plus h. This will be the equation. For minimum there must be equality, and we are trying to calculate energy, not the velocity. If we want to find velocity, we will cancel mass and this 2 will be on right side, so we can find u velocity, but here we are trying to find energy. So energy means kinetic energy, so half mv square is equal to this gmem by re plus h. That's why energy, minimum energy at surface is equal to gmem by re. Here for surface h is equal to 0. So this is the gravitational binding energy at height h. This is the minimum gravitational binding energy at height h. This is the minimum energy, okay, and this is at h is equal to 0. Now there are two types of mass. First one is inertial mass. Let us consider two mass ma and mb are kept on the surface of the earth, and a force, equal force F is applying on both of masses A and B. Okay, so according to Newton's second law, force on A is equal to ma AA. F is equal to ma, so F is equal to ma on particle A, F is equal to ma on particle B, and solving these two equations, since both are equal to F, so solving this equation we will get ma is equal to AB divided by AA into MB. When we are taking MB as a standard mass, a standard kilogram 1 kg, then ma will be equal to AB divided by AA. That is, mass of any object may be obtained by measuring their acceleration under equal force, and using above equation the mass so defined is called inertial mass. So this is the, we are using Newton's second law. That's why this given mass will represent inertial mass. Okay, now gravitational mass. The another way to compare masses of two objects is based on the law of gravitation. We are the second method. This is the earth, and the same two bodies, mass ma and mb, are kept on the earth surface, and the force of attraction on the A will, due to gravitation, will be Fa, and due to gravitation on B will be Fb. So Fa is equal to force on A due to gravitation is equal to G ma me by Re square, and Fb is equal to G mb me by Re square. So equating these two equations, we will get ma is equal to Fb by Fa into mb. When mb is equal to 1 kg, then ma is equal to Fb by Fa. That is, by measuring the gravitational force, we can obtain the mass of the object. The mass so defined is called gravitational mass. Actually, mass can be measured by two ways, by using Newton's second law or law of gravitation. When we are using Newton's second law, F is equal to ma, to measure the mass, that mass is called inertial mass. And when we are applying law of gravitation to measure the mass of the system of mass or mass, then such mass is called gravitational mass. When we measure the mass using a spring balance, then such mass is also called gravitational mass. Actually, whenever we are using a spring balance, we are actually measuring gravitational mass. Since on a spring balance, F is equal to mg. So whenever we are applying a spring balance, we are actually measuring gravitational mass. Now, the next section is concept building question. So this is a very important part of this lecture. Have you wondered a lots of questions comes in daily life, and we don't know what is the actual answer, what is the actual explanation of such questions, like when Newton's seen apple is falling, why apple is falling on the ground on the downward. So like that, a lots of question in daily life comes around us, but we never focus on that. So we are trying to focus on such questions, and we are trying to apply some concept we have studied in previous sections or in these lectures. So we are trying to apply some theories, some formulas, some concept, and try to understand these questions. So let's get started. Aristotle versus Galileo. So this is the lecture. What do you think? Which object will fall faster, heavier or lighter? Have you wondered, have you focused when two objects, a light and a heavy object, is free fall from a same height, dropped from the same height, then have you examined which will come faster, or they will come at the same time to the earth? Have you wondered? Have you examined that? So we are going to explain that which will come faster on the surface, lighter or heavier, or both at the same time. So now see the video. There are some experiment we are going to conduct. So this is the two objects, one is heavier and other one is light. So here you can see heavier object falls fast, but lighter object are falling by late. So this is the practical experiment we have seen many times and in daily life. So this is a and this is the second experiment where two balls are dropped from the same height, but one is heavier, one is lighter. So you can see here, heavier ball comes faster and the lighter balls comes later. But what is the real explanation why it both are not coming at the same time, or what are the real explanation of when a light object and heavy object is dropped from the same height, which will come faster, which will come at the same time or same time. So this is the explanation. We are going to conduct another experiment. So this is a bottle, and this is the vacuum pump, and in the bottle we kept a coin and a feather, and we seal this bottle, and this is a vacuum pump. So we have just started vacuum pump and we created a vacuum inside the bottle. Now let's see what happened. Coin is heavier and feather is very light competitive to the coin. So see here, what have you seen? Both are coming at the same time. Both are dropped at the same height, from the same height, but both are coming at the bottom at the same time. Just see again. See, both are coming at the same time. So what is the explanation? Why it is not happening in real life? Where is the problem? Actually, whenever heavy object or lighter object is dropped from a same height, both object must fall at the same time. But due to air drag or due to external effect, the heavier object comes faster or lighter object comes slower. To consider or to check it correctly, just create a vacuum and then apply the same experiment. You can see that it is independent from the mass, it is independent from the volume, it only depends upon the acceleration due to gravity. And an object is heavier, an object is greater in volume, doesn't matter, it only depends upon the acceleration due to gravity of Earth, which is 9.81 meter per second square. So the acceleration for the both heavier or for the lighter object is same. So both the object will come down at the same time. If this will be conducted in the vacuum, or if air drag will be removed. So here in actual life we seen this difference because of the air drag, and this theory is given by the Galileo. Before that, Aristotle gives the theories that heavier object falls faster than the lighter object, but Galileo explained that both objects, heavier or lighter, falls with the same time. It is because it is independent from the mass, independent from the volume. It only depends upon the acceleration due to the gravity of the Earth, and it is constant for every heavier or lighter object. Now next, conclusion. We have worked hard to cover this gravitation exercise, lecture of this gravitation, because it is very much important from the competitive examination point of view. Why it is important, I am just going to explain you. Please try to understand, because if you cover gravitation, if you have great command on gravitation, your entire physics is easy for you. Because if you have command on gravitation, then you can control over 12 to 15% of physics competitive exam syllabus. because the concept and formula of gravitation matches 99% with the two very big and important chapters, electricity and magnetism, for the physics. What are the similarities? I am just going to explain you. Not only formula but concept is also similar. If you have great command on gravitation, you have just to make some changes, similar changes in the formulas of gravitation, and it can be applicable to electricity or it can be applicable to magnetism. So if you have a great command on gravitation, you will be capable of doing questions from gravitation as well as electricity as well as magnetism. This is how the similarities are. We know that for gravitation, force between two bodies, this is the mass 1 and this is the mass 2. So force of attraction between these two bodies are can be GFAB is equal to Gm1m2 by r square, where G is 6.67 into 10 to the minus 11 Newton meter square per kg square. This is the gravitational constant. In case of electricity, exercise electricity, exactly same formula you can use it. Exactly same formula, but that's it. You have to only replace some basic things like force is same as force. Here mass is replaced by charges, because in electricity exercise there is no significance of mass, there is a significance of charge only. So the m is replaced by q, m is replaced by q, and constant g is replaced by another constant k. Here g is the gravitational constant, here k is the constant for electricity and magnetism. Here k is the constant for magnetism. So there is no difference in formulas, there is a simply replacement of notations. If you have a great command on gravitation, you can just replace the mass, you can just replace the charges by mass, and you can solve that question by the formula of, by the concept of gravitation, and that will be the correct for the electricity and also for the magnetism. In case of magnetism, here that these two m1 and m2 are the poles of the magnet. Okay, so that is a basic difference. See what are the similarities? Gm1 m2 by r square, all are the forces. This is the force between two masses, this is the force between two charges, this is the force between two magnetic poles. So the formula for force is equal to Gm1 m2 by r square, kq1 q2 by r square, km1 m2 by r square, where g is the constant, here k is the constant, here k is the constant. All the values are different for constant. m1 m2 are the masses, here q1 q2 are the charges, here m1 m2 are the poles. R is the distance between the masses, here R is the distance between the charges, here R is the distance between the poles. So likewise, almost all the formulas are similar, all the concepts are similar. Gravitational potential, gravitational field, everything, almost everything is same. So if you have a great command on gravitation, you will be capable of solving problems from electricity and magnetism as well. So student, we have discussed about gravitational binding energy, inertial masses and gravitational masses. We have also discussed about when two bodies from same height, one is heavier and other one is lighter, if they are dropped from the same height, what will happen. So in the next part we are going to discuss about some important question. So stay tuned. Thank you.